Hello folks, and welcome to the day 2 of Jamb Physics in 40 Days. Now, Jamb Physics in 40 Days is a series that is brought to you by Oyalen, where we discuss some problems in Jamb Physics for 40 days. We believe that when you dedicate between 30 to 45 minutes of your time daily, you'll be well on your way to receive all the necessary tools and guidance you need to ace Jamb Physics. So this issue of physics is too hard will become a thing of the past, as you will be getting real training, real lessons on how to solve problems in physics as far as the Jamb curriculum goes. Now, in this day, what we'll be looking at is scalars and vectors, which is one of the topics of the 39 that is in the syllabus for Jamb. And what scalars and vectors basically mean is this. Now, when we look at scalar quantities, they are those quantities that you measure in physics that a simple number will help you understand what they are. That is, they only require magnitude. They don't depend on the direction, right? So like for example, when you look at distance, all you need is just a number to attach to the unit for distance and you understand it like that. So all those kind of quantities that all you need is a number, that is magnitude, they are called scalars. Whereas the types that require a direction are what we call vectors. So they depend on both magnitude and direction, with examples such as force, velocities, displacement, and the likes. Now, we are not only going to be defining that, we should also be able to give examples of scalar quantities rather, and vector quantities. So for scalar quantities, we have things like mass, we have things like distance, we have things like speed, and the likes. Then for vectors, we have displacement, we have velocity, force, acceleration, and the likes. Those ones require direction. Then you should also be able to determine the relative velocity based on a point observation. And what you just need to know here is that when two objects are having their different velocities now, if they are in the same direction, the relative velocity is going to be a difference of their individual velocities. Just picture it like this. If you and someone were to be running in the same direction at the same speed, you will always observe that that person is right beside you every time you look at the person, right? So that means your speed minus the other person's speed will give you a 0. It looks as if both of you are standing still. So that's how you can easily understand relative velocities. However, if they are in opposite direction, you add the velocities up. Then we should also be able to resolve vectors. Now, vector resolution has to do with finding the horizontal component and then the vertical component. Now, one thing you should know is that the horizontal component of a vector, that is vector of horizontal x, is the same thing as cos theta multiplied by the vector itself, or we just say vector times cos theta, while the vertical would be the same vector now multiplied by sine theta. So that's how we work with resolution of vectors. Then from this, you could also get question that asks you to find the resultant of two vectors. So as we solve questions on this, you get more understanding. So if you're ready, get all your materials and then let's solve some past questions on scalar and vectors. Two forces whose resultant is 100 newtons are at right angles to each other. Now, if one of them makes an angle 30 degrees with the resultant, determine the magnitude. So what we have to do here is to first draw a vector diagram where we're going to have two forces at right angles to each other. So, solution. Now, what we have, let's call this the vertical component f of y, and then the horizontal component f of x, right? And then this being the resultant. So let's make this angle here 30 degrees. Okay? Now, if this is 30 degrees with this being 100 newtons, the hypotenuse, we can apply trigonometric ratio, right? We are trying to find f of x, which is the one that makes 30 degrees with the resultant. So in that case, we see that we are looking for the adjacent side, and then we have the, as you can see here, the hypotenuse. So when we are applying that, what we have to use is cosine, right? because cos theta equals adjacent over hypotenuse. Now, applying this, what do we get? Now, cos theta, that is cos 30 degrees, equals adjacent side, which is f of x, over 100 newtons. So in this case, we see that f of x is 100 newtons cos 30 degrees, which will give you 100 newtons times. Now, cos 30 is going to give us 0.866. And when we multiply this, we're going to have 86.6 newtons. So the correct option in this case is option D. Now, this is a question where so many students are often confused. It says, which of the following quantities are scalar? And then we have four quantities mentioned there: electric potential, torque, momentum, and kinetic energy. Now, easily, yes, students recognize that electric potential is a scalar quantity. And then when they look at the options, they see that there's none of the options where only I is mentioned. And they often think that the rest are vectors. But from this, the correct answer is I and IV only, because kinetic energy is also a scalar. And let me explain that. Now, kinetic energy is often given as half mv squared. And many students think because v is mentioned here, definitely it should be a vector, because velocity is a vector quantity. However, the v here is just speed, not velocity. The v here represents speed, because kinetic energy can also be measured as half mu squared. It can also be measured as any way you want to put it, depending on the position you are looking at, and it doesn't care which direction you are going. It is only magnitude it cares about. So that means that in this case, this is a scalar quantity, this is a scalar quantity. But torque is a force, so that is definitely a vector quantity, and momentum is determined also by the distance, the direction rather, that you are moving. So if you are looking at the momentum of an object, you have to consider the direction it is going. So this is also a vector. So the correct answer, I and IV, which is option D. Which of the following is a set of vectors? That is, in the options provided, there is one option that all the components there, all the quantities there are vector quantities. So let's look out and see which one it is. Now, the first option here, we have force, which is a vector. We have mass, which is a scalar. So definitely the answer is not A. Now we can then go to B, where we have acceleration. This is a vector. Velocity is also a vector, and moment is also a vector. So the correct answer is B. However, when you look at C here, you see what we have here is a scalar, vector, vector. But D, we have scalar, scalar, scalar. So if the question were to be changed to which of the following is a set of scalar, the answer would have been D. But since we are only looking for vectors, our answer here is option B. A boat travels due east at 40 meters per second across a river flowing due south at 30 meters per second. What is the resultant speed of the boat? Now, when we consider this, the boat is going in this direction to the east, right, at 40 meters per second. But the river is taking it south at 30 meters per second. The resultant is what you get like this, right? So when we consider this as a right angle triangle, we can also write this as 30 meters per second, right? This will be our resultant. So let's find the resultant. Applying Pythagoras, r squared would be 30 squared plus 40 squared. So r squared here becomes 900 plus, this will give us 1600. So that is r squared is 2500. And when we find the square root of both sides, r will be square root of 2500, which will give you 50 meters per second. The correct option is therefore C. The component of vector x along a direction of vector y is 0 when. Now, looking at this question, we have two vector x and vector y. So we are looking for the angle between them at which the component of x will then be 0. Now, component of a vector x, let's say force of x is given as f cos theta, right? So we are supposed to look for what angle will cos theta. At what angle will cos of that angle be 0? Now we know that cos 90 equals 0, and then cos 0 will give us 1. So that is, we are looking for this at this point, where the angle, that is theta, ought to be 90 degrees. Now let's look at the option. Option A says they are in opposite direction. Option B says that the angle is 45. Option C says perpendicular, which is 90. So the correct option is C. The resultant of two forces, 12 newtons and 5 newtons, is 13 newtons. So what is the angle between the two forces? Now before I go on to solve this, if you're yet to subscribe to the channel, please do so. It's only going to take a second of your time. Please hit the subscribe button. By doing this, you are helping us to be able to make more helpful videos like this, and even many more for as many that would be needing it. So please go on to click the subscribe button, and also you can hit the notification bell icon so that every time we put out a new content, you will definitely be alerted. Now, to solve this problem, we're going to be applying the cosine rule. Now, to apply cosine rule, we have to recall that the rule itself states that the square of the resultant equals the square of the sum of each of the individual forces, that is F1 squared plus F2 squared, then minus 2F1 F2 cos theta. Now, since what we are looking for here is the angle, we are going to apply that cos theta is going to be, now from here we can then say r squared minus f1 squared plus f2 squared, all divided by 2f1 f2. Now let's apply this. What is r? R is 13, so that is 13 squared minus, open bracket, 12 squared plus 5 squared, all divided by 2 times 12 times 5. Now let's see what this gives us. Cos theta therefore becomes, now 13 squared is 169 minus, now 12 squared is 144, 5 squared is 25, this will give us 9, 6, so 169 also, over, now this is 10 times this, that's 120. So what we have is basically 0 over 120, which will give us 0. So theta therefore becomes cos inverse of 0, which will give us 90 degrees. So a body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 newtons and 8 newtons. So we have to calculate the acceleration of this body. Now, we know that force is given as mass times acceleration according to the second law of motion. Now, but this force here will be the resultant force that is acting upon this body, because it is acted upon by two forces. One to the x direction, one to the y direction, because they are separated by 90 degrees, okay? So if that is the case, then we have to find the resultant force here. The resultant force therefore becomes square root of f of x squared plus f of y squared. This will give you the square root of 6 squared plus 8 squared. And what we have here is square root of 100, because 6 squared is 36, 8 squared is 64. Add it together, you get 100. So F is definitely 10 newtons. So acceleration would then be force over mass, and the force is 10 newtons here, and the mass is given in the question as 4 kilograms. Now when we apply this, we'll get 2.5 meters per second squared. So the correct option here is option A. In this question, we're asked that an aircraft attempts to fly due north at 100 kilometers per hour, and then if the wind against it from east to west, now take note the direction of the wind here is due west, is at 60 kilometers per hour. The resultant velocity will be, now in this case, when you look at the options, you see that we have all the angles there at 31 degrees, right? But we don't know, we just have to find out if it is northeast or northwest. So remember that the aircraft itself, right? The aircraft is going north, okay? This direction of the aircraft, the velocity is to the north, while the velocity of the wind is to the west. So the resultant velocity is going to be northwest, right? So we already know that, and since all the options are in 31 degrees, we know that we are going to be dealing with 31 degrees northwest. So it's either C or D. So to find out the final answer, let's find the resultant velocity. Resultant velocity will be the square root of their individual velocities squared. So we have 100 squared plus 60 squared. Now this would give us R equals 100 squared will give you 10,000. 60 squared will give you 3,600. And then when we add this up, we have 13,600. And R here is approximately 117 kilometers per hour. Right? So therefore the correct option here is option C. A body on the ground is acted on by a force of 10 newtons at the point P as shown in the figure above. So here's the figure here. We see this is the force 10 newtons, and then we have the east direction here, and this is point P. And the angle between the equilibriant and the component of X here is 60 degrees. So now the question itself is now saying what is needed to stop the body from moving eastward. So in order to stop this body from moving, we have to apply a force in the east direction. So let's find that. Now, F of X is F cos theta. So the F there would be 10 newtons multiplied by cos theta being 60 degrees. Now this will give us 10 newtons multiplied by cos 60 is 0.5. So our final answer here is 5 newtons in the east direction. So the correct option is option A. A vector quantity can only be completely described when dash and dash are mentioned. So you see here we're trying to define what a vector quantity is. And by definition, we say vector quantity is understood when you mention the magnitude and the direction. That is, it depends on magnitude and direction. So the option that has magnitude and direction is option B. So our answer is B. Which of the following is a vector quantity? That is, of these 4 options provided, 3 of them are not going to be vector, while only just one will be vector. Now let's look at them one after the other. Now, temperature is the degree of hotness or coldness of a body, and this does not depend on direction. It only depends on magnitude. That is understood by using just numbers alone. So it is a scalar, not a vector. Mass is also a scalar, not a vector, because it only depends on magnitude. However, work done, this is the product of force and distance in the direction of force. So you see there that direction is very important to the work that is done. So therefore, the correct answer here is option C. However, time is also a scalar quantity. Which of the following is a scalar quantity? That is, of these 4 options, we have to find the one that is scalar. Now, option 1 is tension, which is the force that is transmitted through a rope, a string, or things like that. So, and you know that force depends on direction, right? So this would be a vector, not a scalar. Now, weight is the product of mass times acceleration due to gravity, and because there's acceleration there, definitely there is direction needed. So this would also be a vector. Now, impulse is force times time, and force requires direction also, so therefore this is also a vector, leaving us with mass. And mass is a scalar quantity, so therefore the correct answer is option D. A single force which produces the same effect as a set of forces acting together at a point is known as the. Now, when you have two or more forces acting together at a point, there's always one force that is able to give us the same effect as the combination of all those forces acting at that point. And that force is known as the resultant force. So the correct option here is option C. The resultant of two forces acting on an object is maximum when the angle between them is. Now, to get this, we're going to apply the parallelogram law of vectors. Now, according to the parallelogram law of vectors, the resultant squared is going to be x squared plus y squared plus 2xy cos theta, taking this to be less than 90. Okay, now in this case, we'll see that the angle that will give us the angle that will give us 1 here would be angle 0, because when we have cos 0, that will give us 1. So that is R is at maximum when theta equals 0 degrees. Because if you apply any other angle here, you get something that will actually reduce 2xy. But when you apply 0 here, this will be 1, and 1 times 2xy will just be added to this, which will also increase the value of R. So our answer is option D. Two cars moving in the same direction have speeds 100 km per hour and 130 km per hour. What is the velocity of the faster car as measured by an observer in the slower car? So this is a case of relative velocities. And I mentioned at the beginning of this video that when working with relative velocities, that when they are in the same direction, you will take a difference. But when they are in opposite direction, you sum it up. So in this case, we see that the two cars are going in the same direction. So the observer in the other car will observe that the faster car will be moving at this velocity. So in our solution, we'll do the difference. That is the velocity of the faster car, 130 km per hour, minus velocity of the slower car, which is 100 km per hour. And then our answer is 30 km per hour, which is in option A. Now here we have solved quite enough questions on scalars and vectors, but there are still very many questions that you can solve as regards this topic. So do well to solve as many as you can using the examples that we have given you in these videos. And if there's anyone you would like help with, please do well to comment that question, drop it in the comment section, and we will definitely attend to you. If you also have any reservation, anything you'd like to discuss to us about, anything you want us to talk about, please put it in the comment section. We'll attend to every one of your comments. And as always, don't forget to like, share, and subscribe to the channels. Thank you. I'll see you in the next video.